Hi there, this is Professor Eckhouse, and I'm going to talk about solving equations with division and multiplication, and of course addition and subtraction, which we did in the last video. All right, so if you're feeling like you need a review before doing this, if you're using the OneNote, you can use the preview before you start in the book to kind of go through and review a few topics that you need to know before you can do this. And it says this one is here. All right, so take a moment to see if you can figure out what simplify, evaluate, and solve mean in your own words. So pause the video and give it a try. Okay, so let's talk about simplify. Simplify means things like with fractions, it means to reduce fractions. Reduce fractions. It means to combine like terms. It means to multiply constants and variables. In other words, distribute, multiply constants and variables, things like that. So combine like terms, reduce fractions to simplest terms, all those kind of things. All right, evaluate. So evaluate means to plug in a known number. That's what we do when we check. So we check, when we get an answer, we go back, we plug it back in and check. A known number for the variable. That's evaluate. This is how we check after solving. All right, so what does solve mean? So solve means to find an unknown value. Find an unknown value that will make an equation true. Okay, so that's what that means. So solving, we only solve when we are working with equations, only with equations, only. All right, we evaluate when we're talking about expressions. It's not equal to anything. It's just an expression. Simplify can be anything, right? We can simplify an expression, we can simplify a fraction, we can simplify an equation. Okay, so let's move on. So let's review division and multiplication properties. So for all real numbers, if A equals B, then we can divide both sides by C and it's still equal. Multiplication property says if A equals B, then we can multiply both sides by some other number, we'll call it C, and it'll still be equal. As long as you do the same thing to both sides, it's still equal. Okay, so that's the key to all of this. All right, so just a little review here. Let's solve these. So pause the video and see if you can get these right. All right, so the goal is to get the x by itself. Here are the x, here's the x, here's the t, whatever it is, here's the m. We just want it to be alone. Okay, so what are we going to do? It is currently being multiplied by 3. So how are we going to get rid of the 3? Well, we have to do the inverse operation, which is division. Okay, so we're going to divide both sides by 3, and we get x equals negative 21 divided by 3 is negative 7. So when I keep saying check, what I mean is 3 times negative 7 equals negative 21. Is that true? So what I did was I put the negative 7 in for the x and in the original equation, and I checked, and it is true. 3 times negative 7 is negative 21. So we know we did it right. We checked. All right, next one. 4 times x. They're being multiplied. Inverse operation is to divide by 4. And we get that x equals 5. So the check would be 4 times x, which is 5, equals 20. And is that true? Yes, it is. So checking doesn't always take a very long time. All right, so t divided by, remember the line means divided by, negative 6. So what's the inverse operation to division? Well, that's multiplication. Multiplication. right? Or 6 over 1, however you want to think of it. So negative 6, so we're multiplying times negative 6 over here. Over here, the negative 6 on the left side are going to cancel out, and we get t equals 30 times negative 6. So 30 times negative 6 is, I believe, negative 180. All right, so let's double check. We're going to check by saying negative 180 divided by negative 6 equals 30. Is that true? Put it in your calculator and check. And yes, it is true. Okay, next one. Why don't you try this one if you haven't already? All right, m is being divided by negative 7, so I need to multiply both sides by negative 7. And for some silly reason, I decided to not put this on my key. So I'm going to work this out with a calculator while I talk here on the video. And my negative 7s are going to cancel out. And I get m equals negative 7. Oh, and I forgot the negative. Negative 7 times negative 42 is 294. So 294. So let's check. 294 divided by negative 7 equals negative 42. Well, take your calculator. I'm going to take my calculator. I'm going to actually do it. And I get negative 42. So that one checks. Okay. So try these. These are a review. See what you can do with them. All right, so if negative p equals 8, what is p equal to? In other words, what is the opposite of negative p equal to? Well, it's equal to the opposite of 8, negative 8. Okay, so p equals negative 8. So if you got that wrong, pause the video and try the second one. All right, if negative y equals negative 11, then what is the opposite of negative y is y? So that means we have to take the opposite of negative 11, that's 11. Okay, so negative y equals negative 11, then y equals 11. And you can also do this by multiplying both sides by a negative 1, if you'd like. All right, so use a reciprocal to solve a linear equation that contains fractions is our next topic. So first let's talk about what is a reciprocal. So a reciprocal is some number that when we multiply it by our number, our original number, we get 1. Okay, so the product is 1. 1, positive 1. So that means if we have 2/3, what is its reciprocal? Well, we'd have to multiply it times 3 halves. So the reciprocal is 3 halves in order to get 1. All right, so when we multiply a number by its reciprocal, the definition is that we get 1. Okay, that's the whole point. Reciprocal is a number that when we multiply, we get 1. So what if our original number was negative 5? Well, remember that that's 5 over 1. So what could we multiply that by to get a 1? Well, we'd have to multiply it by negative 1 over 5. All right, so let's move on. So in order to solve an algebraic expression that has a fraction in front of our variable, we need to use the reciprocal. That's the key here. So we need this 3/4 to go away. We want the x to be alone. So this x is going to be alone. So we need to multiply by 4/3 on both sides. So remember the 12 is just 12 over 1. Or you can use your calculator, however you like to do it at this point. And I know that 12 over 3 is 4. So 4 times 4 is 16. So in other words, let's put this into English. 3/4 times 16 equals 12. Let's say this. 3/4 of 16 is 12. Make sure it makes sense. And if you plug it in, you will see that that is true. All right, next one. Why don't you try this one? All right, so what is the reciprocal of 5/6? You would get 6/5. So you have to multiply this side by 6/5 as well. Again, you can use your calculator, or you can think of it by reducing. So I'm going to reduce this. 30 over 5 is 6 over 1. So 6 times 6 is 36. So I get m equals 36. So let's double check because there's a lot of canceling going on there. We could screw it up. So 5/6 of 36 is 30. So 5, 6 times 36 equals 30. That's two different ways to think about it, English and math. So check it in your calculator and you should get 30. All right, let's try a couple more. So try these on your own if you would like. So I've got negative 4/5 times y. So I need to multiply by negative 5/4. So remember, if I multiply by a negative, I'm going to get a negative. So I get negative 5/4 times 16/1. And the negatives cancel out, the 5s and the 4s all cancel out. And on the left, I'm left with y equals 16/4 is 4/1, or you can just put it in your calculator, and you'll end up with negative 20. Negative 20. All right, negative 3/5. Negative 5/3 is the reciprocal. So I need to say negative 5/3 over here. All right, so the 3's are going to cancel, the 5's are going to cancel, the negatives are going to cancel, and I'm left with x by itself on the left, which was the goal. Negative 5/3 times 9, just use your calculator if you want to, and you're going to get negative 15. But just as a reminder, 9/1 times negative 5/3. The 9 has a 3 in it, there's 3 of them, and the 3 has 1 3 in it. So 3 times negative 5. And we get x is negative 15. Okay, so continuing on. Solve by simplifying first. So combine like terms and then isolate x using the division property. All right, so we're going to simplify by combining like terms. So I've got all of these are the same. Those are all x terms, and these are all constant terms. So everything's together on the right side together, correct side. 9 plus 3 minus 8 is 4. So 9 plus 3 is 12, minus 8 is 4. And that's the x term. Equals negative 90 plus 110 is 20. All right, now I'm going to divide both sides by 4 to get the x alone. And I get x equals 20 divided by 4 is 5. All right, so next one. Try this one and then come back and see if you got it right. All right, so on the left, I get 5 plus 9 minus 6x. So that's 14 minus 6 is 8. 8x equals negative 75 plus 115. You can use your calculator if you want to, is 40. I'm just going to divide both sides by 8. And I get that x equals 40 divided by 8 is 5. And again, you can go check these, but the video would be way too long if I checked every single one. So I'm going to continue on. All right, this one has the constants over on the left and the x terms on the right, and that's fine. Just combine like terms. So negative 18 plus 32 is 14. 6 plus 9 minus 8x is 7x. Now to solve for x, I'm going to divide both sides by 7. And I get 14 divided by 7 is 2 equals x. And again, you could go plug that in and double check. All right, next one. Give this one a try. All right, again, I have all my x terms are together. How nice. And all my constant terms are together. It doesn't matter which side they're on. So negative 125 plus 140 is 15 equals 3 plus 6 minus 4 is 5. So 5x. Now I'm going to divide both sides by the 5 that's with the x there so that I can get the x alone. And I get 15 divided by 5 is 3 equals the x, or x equals 3, right? So you can write it either way. X equals 3, 3 equals x. It doesn't matter. All right, now we're going to combine different properties together to solve these. All right, so there's a lot of problems here. So you can fast forward through any that you feel like you've got. You can pause and do problems, and I'm going to stop having you pause. You can pause if you want to pause, and I recommend you pause every single time. So first we have to distribute. So we get negative 4 times x and negative 4 times 3, and that's going to give me negative 4x. Negative 4 times 3 is minus 12, and then I have plus 12 equals 4. Notice that my plus 12 minus 12 actually cancel out. That becomes 0. And I am left with negative 4x equals 4. So now I need to divide both sides by a -4. And I get x equals 4 over -4 is -1. All right, next one. Why don't we give this one a try? All right, so I've got 5 times x and 5 times 4. So I get 5x plus 20. Oh, look at that. Minus 20 equals 45. So my plus 20 minus 20 goes away, and I get 5x equals 45. So now I'm going to divide both sides by 5. The 5's go away, and I get x equals 9. Again, you could check any of these that you'd like to check. All right, what if there's a variable on both sides? Let's try one of those. So what you're going to have to do here is you're going to have to add one of the x's to get it to the other side. Well, I'm going to add the 9x so that I can get the x's on one side and the constant terms on the other. So sorry, I missed my plus. So there we go. Negative 8x plus 9x is just x, and the only thing we have left on the right is a 3. All right, why don't you try that one? All right, so I get plus 5x plus 5x. My 5x's go away. And I get 10x equals -10. Divide both sides by 10. And I get x equals -10 over 10 is -1. All right, try the next one if you'd like. All right, I'm going to subtract 2x to get it over to the left. That way I have the constants on one side and the x's on the other, and that's my goal. 8x minus 2x is 6x equals -42. So don't miss this negative right here. It stays in front of the 42. And now I'm going to divide both sides by 6, and I get x equals -42 over 6 is -7. And here's a similar one if you'd like to try it. All right, I'm going to add 6x to both sides to get the x's over on one side by themselves, and I get 12x equals what's left on the right side, 48. Now I'm going to divide both sides by 12, and I get x equals 4. All right, another one. So now, if I move the 42 to the right, I would have to do another step of moving the 5x over to the left. So instead, and you can do that if you want, I'm just going to say I like to have as few steps as possible. So it doesn't matter if x is on the left or the right. It really doesn't matter. So if it's on the right, that's fine, as long as it makes your life easier, right? So less steps. That's what I always go for. Less places to make mistakes. So now I've got a 7x, so I'm going to divide by 7. And I get -42 over 7 is -6 equals x. Try another one similar to that. All right, so after looking at this for a moment, I decide I'm going to add 4x to both sides. It's not always apparent when you first look at something, but if I did that, that means I end up with -24 on the left. -x plus 4x is 3x on the right. And now all I have to do is divide by 3. I have no more steps besides that. -24 over 3 is -8 equals x. All right, so equations with variables and constants on both sides. All right, so I just take a moment to look at it, and I usually go for whatever's going to make my x term positive. You don't have to do that, do whatever you want, but just you make a plan to get the x's to one side and the constants to the other. So I'm going to subtract 4x first, and you can do it all at once if you want to, but sometimes that's a little confusing. So I get 6x minus 4x is 2x. I've still got a 14 right here, equals 20. So now my x's are on the left, I'm going to get the constants to the right. So I'm going to say minus 14, and I get 2x equals 6. All right, so I'm going to divide both sides by 2. And I get x equals 3. All right, next one. All right, so I'm going to get the x's to the left. So minus 2x, and the x's go away right there. And I get 3x plus 11 equals 38. I am going to subtract 11, and I get 3x equals 32 minus 11 is 21. I'm going to divide both sides by 3. And I get a little more room here. And I get x equals 7. Okay. And I may have subtracted wrong. I'm just double checking. Oh, I wrote 32, didn't I? I'm like, something is wrong here. Something is wrong. So I wrote a different number. It should be 38. So 38 minus 11 is 27. Magically, it still was divisible by 3. I don't know how I made that mistake. 27 divided by 3 is 9. So I should get 9. All right, next one. Let's see. Make a plan. I think I'm still going to get the x's to the left, because look what happens when I add 9x. I end up with a positive negative 6 plus 9 is 3x. Minus 3 equals 6. Now I'm going to add 3 to both sides, and I get 3x equals 9. And now I'm going to divide by 3, and I get x equals 3. All right, one more of those if you want to give it a try. All right, I'm going to add 4x to both sides. And I'm probably going to end up with a negative. That's all right. So I get negative 2x minus 1 equals 15. And I'm going to add 1 to both sides. And I get negative 2x equals 15 plus 1 is 16. Now I'm going to divide both sides by negative 2. And you should get x equals negative 8. All right, last topic is a little bit challenging. So we're going to solve equations that have fractions in them by clearing the fractions, and it will make life so much easier when you have algebra with fractions. And this works at all levels of difficulty of fractions. So reminder, what is a least common denominator? It is the least common multiple of everything of the denominators, of all denominators that are in the problem. A least common multiple. All right, so you need to know what the least common denominator is for this one, because what we're going to do is look at all of the denominators and find the least common denominator and multiply every single term by that least common denominator. Well, here it just happens to be 3. So I was trying to keep it simple. So I'm going to distribute a 3 across everything, every single term. So I'm going to multiply it times this one and times this one. I'm going to multiply it times this one and times this one. Okay, so I need a lot of room here. So I'm going to come over here to the right. I'm going to take 3 times 2/3 x minus 3 times, because there was a minus there, times 9. I'm not going to have enough room. And I'll move that over to here. All right, and then I've got equals 3 times the 4 that's there on the right side, plus 3 times the 1/3 x. So if you did this right, every single denominator should cancel out. So I've got 3 over 1, right, times that, so the 3's cancel out. So I'm left here with 2x. Minus 3 times 9 is 27, equals 3 times 4 is 12, plus now, check out, I've got the 3 over the 1 times the 1/3, and the 3's are going to cancel out. And I get plus, what's left? 1x, so just x. Wow, look at that, so much simpler. All right, so I'm going to bring my x's over to the left, minus x, and I get 2x minus x is just x. Minus 27 equals, all I have left on the right is 12. All right, then I have to add 27 to both sides. And I get x equals 12 plus 27 is, made a mistake on my keys, so I'm just pausing here thinking about it, 39. Yeah, so hopefully I got that right because my key is wrong. 4 plus 1/3. I'm going to double check. I've got 3 times 4 is 12. I've got 3 times 1/3 x is just x. I've got 3 times 9 is 27, and 3 times 2/3 is 2x. Yep, I think I got it. All right, so moving on. If you would like, you can try that one. Okay, so the least common denominator is 2, which means you're going to multiply both sides, every single thing, that one, and that one, and that one, and that one, by 2. So I've got 2 times 1/2 x minus 2 times 6 equals 2 times 8 plus, watch your signs as you go, 2 times 3/2 x. All right, 2 times 1/2 is 1. Then I just get x. Minus 2 times 6 is 12. Plus 2 times 8 is 16. Oops, not plus. Equals. Equals. And 2 times 3/2, the 2's cancel out, and I get plus 3x. All right, so I'm going to subtract 3x from both sides. And I get negative 2x minus 12 equals 16. And I'm going to add 12 to both sides. And I get negative 2x equals 28. Now if you divide both sides by a negative 2, you should get x equals negative 14. All right, 2 more problems. So what is the least common denominator of all of these numbers? 5, 4, and 10. So I always go for the biggest number and check it, 10. 5 goes into it before, doesn't. So then I'm going to double this number and say 20. Okay, so 10 goes into 20. Does 4 go into 20? Yeah, it does. Does 5 go into 20? Yes, it does. So the least common denominator is 20. So that means I have to multiply everything by 20. Oh my goodness. By 20. Yikes. Okay, so I get 20 times x minus 20 times 2/5 equals 20 times 3/4 x. I try to line up my numbers so that I can cancel things a little bit easier. Plus 20 times 1/10, or 1/10 of 20. I'm going to put that in black, sorry. 20 times 1/10. Okay. So 20 times every single thing. Check all your signs. I've got a minus, and then I've got a plus, I've got an equals. Okay. All right, so first one is 20x minus 20 times 2/5. So I get 20 and 5. Both have 5s in them. This one has 1, and this one has 4. So that means I'm left with 4 times 2. 8. Equals 20 times 3/4. 3/4 of 20 is 15. 15x. And then 1/10 of 20, well, 20 divided by 10 is 2. All right, so I'm going to subtract 15x from both sides to get x over here on the left. And I get 5x minus 8 equals 2. And I'm going to just add the 8 to both sides. And I get 5x equals 10. And I'm going to give myself a little more room here. And I'm going to divide both sides by 5. And I get x equals 2. Whew. Oh, that was long. but you know, once you've got the fractions gone, it just makes the algebra so much easier. All right, so how would you get rid of the fractions here? What is the least common denominator of 5, 2, and 10? Well, in this case, it is 10. So you're going to multiply both sides, every single thing, by 10. All right, so we get 10 times x plus 10 times 3/5 equals 10 times 1/2 x. So be a little methodical in the way you write so that you can keep track of what's on top and what's on the bottom. 2/10. Double check everything. All right, so we've got 10 times x plus 10 times 3/5. So the 10 and the 5 reduce, so I get 1 and 2. So 2 times 3 is 6. All right, 10 times 1/2. What's 1/2 of 10? 5. And don't forget the x. And here, the 10s just cancel out altogether, and I get 2. All right, so now I'm going to subtract 5 from both sides, 5x I mean, and I get 5x plus 6 equals 2. And now I'm going to subtract 6. I meant to do that in red. Subtract 6 from both sides, and I get 5x equals -4. Now, it's not perfect, but that's okay. It doesn't mean you did anything wrong. We are working with fractions here. So we get x equals -4/5. And that's the final answer. All right, that was the last one of a very large set of examples. So have a great night or day, and thank you for watching.